Okay, hi, good morning everyone. So today I'm going to present topic 1.2 resolution of force. Okay, first of all, I want to apologize because I cannot carry out uh, real time exam because real time class because I'm involved with SPM candidate. Okay, so without wasting any more time, I'm going to present subtopic 1.2 resolution of force. Okay, okay, resolution of force is a process of resolving a force into two components. Okay, first question, why you need to resolve the force? Okay, in previous lesson, we can sum out the force if the force is in the same axis. Okay, we have two axes. It's either x axis or y axis. But for the question which involve the force that is not right angle or force which is not in y axis or x axis, we need to resolve the force. Okay, same goes to this example. Example number one, the force. Okay, we saw a man. Here is a man pulling a trolley full of boxes. Okay, so we can see the direction of force is upward, but the resultant force, we can see what happened to the trolley. Trolley will move to the left. That is the what happened at the end of this process. Okay, so we can see if we resolve this process, we can see another two forces in x axis and also y axis. Okay, one process is in y axis, vertical axis, and the other force is in y axis. Okay, why we need to resolve this force in order for us to find the acceleration, the other force lah. We want to find not other force, the other physical quantity such as friction, reaction force, acceleration, or any physical quantity lah mentioned in the question. Okay, next we're going to move to next slide. The motion of the box is to the left. Okay, what I have told you just now. Even the direction of the applied force is inclined upward. Okay, this is due to the pulling force having a horizontal component and the vertical component. Next, okay, here is the force acting when the man pulling the trolley with full of boxes. Okay, it is your job to resolve the force into y component and also x component. Given to you the angle, okay, angle where the trolley operate. Okay, okay, in order for you to find the horizontal and vertical component, okay, you need to know the trigonometry lah. Okay, soka tua kan. Soka tua, if just like teacher mentioned before in your class, we have been revised this. Okay, trigonometry. Okay, when we have right angle triangle here, okay, this is 90 degree angle. So you can find the Fy and Fx component. Okay, cos x, so kah tua. Okay, cos Fx over F. Fx over F. Okay, you will find the F cos theta. Okay, F cos theta, F cos theta is equal to Fx. Okay, here I need to cos theta. Okay, cos theta. Cos theta is equal to Fx. Then when you want to find the Fy component, sin theta is equal to Fy over F. Then we will find Fy using trigonometry, circle what? Okay, F sine theta. Okay, you need to resolve one by one. Okay, to Y component and also X component. Okay, we have example here. Example 1 is solving problem involving uh, resultant force and resolution of force. Okay, a wooden block is pulled by force T. Wooden block being pulled by force T. Make sure you understand the question. The incline at the angle of 30 degree above the horizontal surface as shown in the figure 1.16. Okay, here we have wooden block. Okay, the reaction force is 5 Newton, weight is equal to 25. Frictional force, you have to identify all the value in your question. Okay. Now it's the magnitude of horizontal component Tx and vertical component Ty. So you need to resolve this force. Just like teacher told you just now, magnitude of pulling force T is equal to 4T given. Tx, how to find Tx? Tx is the horizontal component Tx using trigonometry, just like I say just now. Okay, T cos 30 is equal to T substitute 4T cos 30 is equal to 36.64 to the right. Okay, Tx to the right. Okay, Ty T sin 30 is equal to, okay, substitute 4T sin 30 is equal to 20 Newton upward. 20 Newton upward. Okay, next. Okay, B, example B, calculate the magnitude and direction of the resultant force acting on the block. Okay, resultant of horizontal component. You have to sum up all the force on horizontal component. Okay, we have two forces. Okay, you already find Tx acting to the right and Fr, frictional force acting to the left. Tx minus Fr is equal to, okay, you find the answer is 16.64 Newton to the right. Why to the right? Because we consider Tx is greater than Fr. So the resultant force is greater to the right. Magnitude of force, greater force is acting to the right. Resultant of vertical component, sorry, salah. Okay, vertical component Fy. Okay, teacher, ni ada typing error kat sini. Ni vertical. Vertical indicate the y axis. Okay, Ty plus R. Okay, why Ty plus R? Okay, R is I think upward as well as our Ty. Okay, is equal to W. Okay, minus W is equal to 0. Okay, so the resultant force, okay, Ty is equal to 20 plus 25 is 25 lah. Okay, then minus 20 minus 25. 25 ni. Banyak salah. Okay, so the resultant force is equal to 0. Okay, next. Question C, calculate the acceleration of the block if its mass is 1.8 kilogram. C. Okay, F is equal to ma. We use formula of Newton's second law of motion. F is equal to ma. Okay, substitute all the, list down all the information in your question. Okay, F resulted on X axis horizontal component 16.64 Newton. Mass of the block is given by 1.8 kg. Acceleration A is equal to F over M, substitute and we get the answer 9.24 meter per second square. Make sure you use the correct unit. Okay, example 2. Okay, figure 1.17 show the free body diagram of the sliding down a smooth block, sliding down a smooth inclined plane. Normal reaction given by 10 Newton. We have block and we have the weight of the block given by 20 Newton and the angle of the sliding block in this inclined plane is 60 Newton. sketch and label the component of the weight of the block parallel to the inclined plane and the component of weight of the block perpendicular to the inclined plane. Okay, here is the free body diagram. Okay, when you draw free body diagram, make sure you draw all the possible forces that acting on the object. Okay, we have W here. Okay, W acting downward. So you have to resolve the weight into X and Y component because it is not in our axis, not in horizontal nor vertical. Okay, this is the free body diagram. Okay, then you need to solve question number B. Okay, calculate the resultant force acting on the block. Okay, resultant force, how to find resultant force? Okay, first you need to resolve the force, the weight into Y and also X component. Resultant force perpendicular to the inclined plane is equal to 10 plus minus 10 is equal to 0 Newton. Okay, you will get the answer if you draw the free body diagram properly. Resultant force on the block is equal to 17.32. Okay, you will find 20 sine 60. Okay, we'll find the resultant force acting on the block. Ni force perpendicular. Okay, perpendicular to the inclined plane. Perpendicular, that mean ni adalah normal reaction lah. Normal reaction minus F, WY. Ni normal reaction minus WY. Resultant force ni awak akan dapat kat Y, WY 20 cos 16. And the last one is C. What is the acceleration of the block if the mass is 2 kg? So you find the resultant force of horizontal component is equal to 17.32 Newton. Mass of the block is equal to M. Mass of the block is equal to 2 kg. Acceleration of the block given by Newton's second law of motion. A is equal to F over M. Then you substitute into the formula 17.32 divided by 2.0 and the answer is 8.66 meter per second square. Okay, so as for today, homework, I want you to complete class kit module, and also for those who already complete presentation PBL for 1.2 and 1.3 subtopic, I want you to combine all the answer and create a scrapbook. Okay, I want you to create a scrapbook. Okay, the solution. I want you to do the solution and make it as a scrapbook. Okay, that's all for today. Thank you so much for watching, guys. Okay, bye. Have a nice day.